Hi, let's do a few examples of factoring using sum and difference of cubes. I've written the formulas up here for you, but we factor using sum and difference of cubes when we have a binomial, something with two terms, and each one of those terms can be written as something cubed, like an a cubed plus a b cubed, or an x cubed minus a y cubed. It works if I have a sum or a difference, an addition sign or a subtraction sign. Each of those can be factored into two different pieces that look something like this. Meaning that if I were to FOIL this out, distribute, and combine like terms, I would end up getting back to where I started. If you notice, there's a pattern here. We always start with the same sign, it always changes to the opposite sign, and then it's always a plus sign in the back. So some instructors say SOAP for short, or to help you remember. So same, opposite, always positive, SOAP. In the first piece, that's my first term. The second one is my second term. Here, I have my first term times himself. Here I have the two terms multiplied together, and then this last one is the last term times himself. So you can kind of see the pattern there to help you remember the different formulas. Let's do a few examples. One of them is a w cubed minus 8. I have two terms, a binomial. There's no greatest common factor that I can pull out of each of those terms. But what I need to do is I need to get it to say something cubed minus something cubed, because right now the only thing that I have cubed is the w. So let's see if we can rewrite this problem without changing his value into two terms that are cubed. I have the w that's cubed. What cubed, what times what times what, gives me 8. Can I say 2? 2 cubed is 8? So now it looks like the form that I need. I have two terms, both being cubed, and I can use my difference of cubes formula. SOAP, same sign, opposite sign, always positive. I'm going to fill in my blanks now, my different pieces, with my first term, which is in this case the w, my second term, which is now the 2, my first term times himself, so w times w, I'm going to say w squared. My middle term is the 2 multiplied together, so w times 2, I'm going to say 2w. And then my last term multiplied by himself, so 2 times 2, or 4. This is the factored version of my original. You can always double check it by distributing through, combine your like terms. I promise you should end up getting w cubed minus 8. Let's look at this one. This one has an addition sign in between, so this is a sum. But it doesn't quite look like a cubes problem yet because I need both of my terms to be something cubed. And right now the only thing that's cubed is my x. So can you make that 27 into something cubed instead? How about a 3? Isn't 3 times 3 times 3 27? So now I have a binomial, two terms, that are both cubed. And now I can use the sum of cubes formula. Here we go. SOAP, same, it's a plus sign now, opposite, always positive. And now I can just fill in my blanks. I have my first term, x. I have my second term, 3. I have my first term times himself, so x times x. Let's say x squared. I have the two terms multiplied together, so x times 3, or 3x. And then I have my last term multiplied by himself, 3 times 3. Can I say 9? This is the factored version then, using my sum of cubes formula. I hope that helps.